Right, thank you very much. Boys and girls and colleagues, good morning. Today we are going to look at analytical geometry. Mostly that will be grade 10 and grade 11 revision. Of course, that is the work that we did in grade 10 as well as grade 11. Of course, since now we are preparing for the final paper, you have seen how you have performed now in this trial examination that you wrote. I think it's very important now. This is one of those topics that you must make sure that you collect as much as possible. Please pay attention throughout these sessions. If you have questions, please ask those questions so that we can get the clarity. It's very important, and I believe that if you send those questions through this presentation, I think the second quarter now of this presentation, then I'll be able not to respond to your questions. Right now, let us start, boys and girls. Of course, we know analytical geometry, right? We know analytical geometry. It takes plus or minus 40 marks. Now, out of this 40, if you can just make sure that you run about plus or minus 30, then I think you'll be on a good side. Right, what is it that we must look at on this one? Of course, we need to remind ourselves about the tools that we need before we can solve the analytical geometry, which is very, very important. Of course, when you look at this one now, we have the revision from grade 10, of course, as well as grade 11. And now you remember now, most of the time here, we will be having the distance between the 2 points. Of course, you remember the distance, the formula that you use when you determine the distance between any 2 points, or the length of the line segment AB. The line segment AB. Of course, now we are going to have, this is the formula that we use. AB is equals to the square root of x squared minus x1 all squared plus y2 minus y1 all squared. You see, it is very important now to familiarize yourself with what? With the formula sheet. It's very, very important, right? Of course, on top of this one as well, I can also add the one of, say, now AB squared now is equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now everything then must be inside the square root. No, everything now must not be inside the square root here because we have 2 on this side. Now, why am I adding this formula now? Remember now, under this the distance formula, now you'll find that we have 2 possible questions. You have 2 possible questions that you can get on this. So the first one, of course, they can ask you to determine the length between 2 points A and B. Right, and then the other one, you'll find that the distance will be given, right? The distance will be given, and the only thing that you can do there is to find the value of x or the value of y. Of course, the first formula is still relevant, but now most of the time I've realized that most of the learners, once they have the square root, it's not easy for them to get rid of that square root. Of course, that is why now I'll encourage some of you now to go through this way, where you have AB squared, you just substitute the length of AB, and now you substitute x2 as well as minus x1, then y2 minus y1. Right, of course, that is for the distance, the length between the 2 points A and B. Of course, the next thing that you must look at as well is, now you must make sure that you have the coordinates of A as well as the coordinates of what? As well as the coordinates of B. Right, now I think now that is the first thing that you must look at. And now the second one, of course, it will be what? It will be the gradient, right? You still remember the gradient formula? Yes, we still remember the gradient formula. MAB equals to y2 minus y1 divided by x2 minus x1. It's very important, this one. But most of the time, I would really like to add this one to say, what do I need for me to determine the gradient formula? Of course, I must have what? I must have the 2 points. I need to know the coordinates of A, and also I need to know the coordinates of what? The coordinates of B. But you'll agree with me, in some situations you find that you have only 1 point. In that situation, what is it that you must do? Then, of course, later on, we look at that one to say, okay, if I have only 1 point, then it means for me to have the gradient, then there is something that I need that will enable me, that will help me to have the second gradient. Good. Now, the third one, of course, it will be the coordinates of the midpoint of the line segment AB. I believe that you still remember the formula there. Here's the formula. that is m there into x1 plus x2, then we divide everything by 2, then y1 plus y2, then divide everything by 2. Of course, also on this one, the question can be asked in two ways. Then they can give you the midpoint as well, and then they ask you to determine what? To determine the coordinates or the point x or y. Right. Now the last one, of course, it will be the standard form of the equation of a straight line, which is y is equals to mx plus c. Or you remember that if you don't use this one, of course, you can take the second one, where you have y minus y1 is equals to m into x minus x1. Of course, most of the time when you use this one, you remember now you must have a point on that line as well as what? As well as the gradient. It's very important. M stands for our gradient. You remember earlier on you talked of the gradient, and of course now x1 and y1, you need to have a point on that line. Right. Now, we are saying now, we also have what? The collinear points. Remember now, these are the points that lie on the same line. These are the points that lie on the same line, right? What do you know about the collinear points? Of course, they have the same gradient. Remember now, I'm referring to this line here. I'm referring to the line, if this is A, this is B, and this is C, then we agree that now the gradient of AB is equals to the gradient of BC. The gradient of AB is equals to the gradient of BC is equals to the gradient of AC. It's very, very important. Then, of course, we'll just look at the given information. Then you choose. It's either you take the gradient of AB is equals to the gradient of AC, or you take the gradient of AB is equals to the gradient of BC. This will just depend on the type of the questions that you have, right? Boys and girls, like I said, it's very important when you get to the distance, when you get to the gradient, the midpoint, of course, the equation of the straight line is straightforward one. You need to remember that these questions can be asked in more than one way. Then when you practice this one, make sure that you check both ways, because if you only concentrate on the distance, now if the distance is given, what is it that you're going to do? Right? And the last one that we can also add under the angle of under the gradient there, that will be the angle of inclinations. Remember now, it's still under the gradient here, where tan theta here is equals to what? Is equals to m. Of course, I'm happy also to write this one here, because you will see that sometimes on some of the questions you get that the angle is given. You find that the angle is given, and now the question then asks you to determine the gradient. Now you remember, for you to determine the angle, you need the gradient. And also you can do the same thing here. If the angle is given, then you can use the angle to determine the gradient. I think boys and girls will agree with me. It is very important each and every time to make sure that before you start with this, to answering the questions, make sure that you just give yourself a short summary about the analytical geometry. What is it that you need? What are the tools that you need to solve this type of questions? Right. Now, let us take these questions quickly to see what is it that we need on this one here.